everyone, so welcome to the lecture number 27 of chapter 7. In the previous lecture we have discussed about a theorem, that is theorem number 7.8, where we have discussed the relationship among the three sides of a triangle. According to the theorem 7.8, we have discussed if in a triangle three sides are given, okay, AB, BC and AC, then the sum of any two sides is greater than the remaining third side. Okay, for example, here the side AB and BC is added so that their result is greater than AC. Sum of BC and AC is also greater than the third side AB. Similarly, the sum of AC and AB is greater than the third side BC. This is the theorem number 7.8. Okay. Now, based on that concept, today we are going to discuss about a question or an example from your NCERT book. That is example number 9. Right? So let us understand the question. So it is given that D is a point on side BC of a triangle ABC. Okay? So it is given D is a point. Where D is a point? D is a point on which side? On the side BC of a triangle ABC. So let us first draw a figure ABC. This is the triangle ABC. Let's say this is ABC. Now it is given D is a point where? On the side BC. So BC is a side. Now on this side BC we have to take a point D. Let's say this is the point D. Such that AD is equal to SC. Such that AD is equal to SC. Okay, AD means we have to join A with D. Right. So that AD is equal to AC. That means this side is equal to this side. Now it is correct. Next, from this statement we have to now show or we have to prove that AB side is greater than AC side. AB side is greater than AC side for the triangle ABC. Okay? So we have to prove it. So let us write what is given here. Since it is given AD is equal to SC, or you can say SC is equal to AD, it is given, right? So we have to prove that this side AB is greater than this side SC. Okay. Next, let's prove it. How can we prove it? See, since it is given AC side is equal to AD side, yes or no? Yes. So if we consider the triangle ACD, then this side is equal to this side. Now according to theorem 7.2, we know if in a triangle any two sides are equal, then their opposite angle must be equal, right? So here also you can write implies this angle, because this is the opposite angle of this side. Similarly this angle, this is the opposite angle of this side. So for the triangle ACD, this angle is equal to this angle. This is verified already. So angle ADC is equal to angle ACD. You know it. From theorem 7.2. You can write it in the given statement, not in the proof statement. You can write here, but it is very easy to write here. It is very convenient to write here. Now, in the proof section, what do we have to do? See, let us consider the triangle ABD. Okay. So let us consider triangle ABD. Which triangle? ABD. Okay. Just read my hand. Triangle ABD. Now, tell me, if I extend BD to a point C, then for the triangle ABD, this is denoted as an exterior angle. Yes or no? If this is ABD, then this angle is an exterior angle. So this angle is the exterior angle. You know it. Okay. So you can write then ADC angle is exterior angle. We know in a triangle the exterior angle is equal to, suppose this is the exterior angle. The exterior angle is equal to the sum of two interior opposite angle. We know it. It is a theorem. So the exterior angle is equal to, these are the two interior opposite angle, right? So you can write exterior angle is equal to angle 1 plus angle 2. You know it. Okay. So the exterior angle is equal to sum of two interior angles. Then there is a question arise. Since this term is the sum of another two terms, then can we write this is the largest angle, or this is the largest largest digit among the three digits? I think you didn't understand. Let me tell you an example. Suppose I can write 5 is equal to 2 plus 3. Here I have written exterior angle is equal to this angle is equal to this angle plus this angle. So whenever these two angles are added, they give this angle. Similarly, here whenever 2 and 3 are added, they give 5. So both the examples are quite similar. Now let us conclude one thing. Can we write 5 is greater than 2? 5 is greater than 3? Can you write it? Because this is the sum of these two. Do you understand? We can write 5 is greater than 2, or you can write 5 is greater than 3. Let's take another example. Suppose I have to write 14 is equal to 10 plus 4. So here, whenever these two terms are added, we get 14. This is the result. Can this result is greater than this term and greater than this term? Obviously, 14 is greater than 10 and 14 is also greater than 4. If two terms are added, they will give you another term, then definitely the result is greater than the other two terms. Yes or no? Yes. Any term you can take. Suppose you take 100 is equal to, you have to write 99 plus 1. Then definitely the result is greater than this one and this result is greater than this one. Similarly, here what do we get? Here we get exterior angle. That means this side is equal to sum of these two sides or sum of these two angles. Okay, that means we can write that exterior angle is greater than this angle. That exterior angle is also greater than this angle. Do you understand this? This is very easy to understand. You can compare it with this type of example, then you could easily understand. Okay, since exterior angle is the sum of any two angles, that means this angle must be greater than this angle, must be greater than this angle. Do you understand this? Okay, so let us write this statement in mathematical expression. So here, for this triangle IBD, this is the exterior angle, and this angle are known as interior opposite angle of this exterior angle. So this angle is equal to this angle plus this angle. It means this angle is greater than this angle, and this angle is definitely greater than this angle. Let's say this is 40 degree, this is 30 degree, then this must be 70. Correct? Now 70 degree is definitely greater than 40 and 70 is definitely greater than 30. Is it correct? Yes. So we can write ADC angle. ADC angle, that means the exterior angle, is greater than this angle, ya fir this angle. So I will take this angle. So this angle is greater than this angle, AB. You understand this? Okay. Next thing, we know this angle is equal to this angle, ACD angle. Why? Because AC is equal to AD. So this angle is equal to this angle for the triangle ACD. Is it correct? So in the place of ADC, we can substitute ACD. Correct? Is greater than AD. Why? Just write the reason. The reason is that ADC angle is equal to ACD angle. Did you get this? So what we have found? We have found that for the triangle ABC, ACD angle means which angle? ACD means this angle. Which angle? This angle. Is greater than which angle? ABD. That means this. So according to the theorem 7.7, what we have discussed? The 7.7 theorem we have discussed. If in a triangle, two angles are not equal, they are unequal, then the side opposite to the larger angle is longer. Okay. So here for the triangle ABC, if angle B is greater than angle C, then the opposite side of the larger angle is AC and the opposite side of the smaller angle is AB. Then the opposite side of the larger angle is greater. We have understood it. We have solved it in the theorem number 7.7. So here also we get for the triangle ABC, this angle, it means this angle is greater than this angle. So simply we can write angle C is greater than, for this ABD, for this ABD we can simply write angle B. Okay. Since this angle is greater than this angle, so the opposite side of this angle, that is, what is the opposite side of this angle? If we consider ABC triangle, AB, and what is the opposite side of angle B? AC. Then the opposite side of the larger angle is longer. So finally we have found AB greater than AC by theorem 7.7. Do you understand this? So finally we have got AB is greater than AC, then we need to prove, and here we have proved it. Okay, so hence it is proved.